Hello, Accelerated Math 7-8 students. We are starting our 16th video, which is Module 9, Lesson 6, and it is called Angle Problems and Solving Equations, and we find that on page 36 of my comp book. Sorry, 37. I need to change that. Okay, so here we go. This is what we have going on today. Angle Problems and Solving Equations. Today we are going to use vertical angles, adjacent angles, angles on a line, and angles at a point to write and solve equations. It's a really fun lesson. I think you guys are going to like it. The question that I want you to be thinking about as we go today is, how do you write an equation from a word problem? Think about that. Some angle facts and definitions. I know you hate this page, but we have to get it out there because you don't know this stuff yet, and you have to know this in order to do the lesson practice. So I made a table, and I will just go ahead and show you all of it. And as you can see on my table, I did make an error, so I need to fix that really quickly. Sorry for that. Basically, what this table does is it gives you the word and the definition and an example of it, okay? And so let me fix this really quick and then I'll start. Okay, so we have angle facts and definitions. Adjacent angles. The word adjacent means right next to. So the definition of adjacent angles are two angles that share a common side. Here's a picture of two adjacent angles. We have angle ABC, with that little black, and then CBD, this little one, and they share a common side of BC. Do you see it? So here's one angle right here, here's another angle right here, and they share this common ray, BC. So the way we read it is angle ABC and angle CBD are adjacent angles because they share this common side right here. Okay? Good. Next one is vertical angles. Okay? Vertical angles are two angles that sit opposite of each other. Okay? And so if we look at it, we have angle ABC. C is opposite of, what do you think? Let me say that one again. Angle ABC, so we're actually talking about this one right here, is opposite what? Angle DBE. Do you see it? So those are called vertical angles because they sit opposite of each other. There's also two more in here. Can you see them? Angle ABD is opposite angle CBE right there. So this angle is across from this angle is across from this angle. They're opposite of each other, so that's why they're called vertical angles. I know it's weird, vertical. You would think up and down. Well, this one is up and down. These are not up and down, but they're still called vertical angles. Yes, I know. They're trying to make the name concise. So vertical angles are two angles that sit opposite of each other. So again, angle ABD and angle CBE are vertical angles. Moving on to the next one. Angles on a line. So here's a line. Do you see it? One straight line. And that line that we're talking about is called line ABD. Do you see it? Well, this one says angles on a line, so we're talking about the angles that sit up above that line. So angles on a line, it says the sum of the angles is 180 degrees. Okay, so that means that angle ABC right here is a certain number of degrees, and angle CBD is a certain number of angles, and so added together would be 180. So the two angles that are on a line in this one are angle ABC and angle CBD, and if you add them together, you get 180 degrees. That's going to be really important in just a second. The next one we have is angles at a point, and this one is a little bit confusing.
Yes.
Hold on.
Well, Miss Kate, Miss Campbell,
Sorry for that.
Miss Wertz, and Marcia L., please go to room 710, Lynn's room. Thank you.
Sorry. So we have angles at a point. Angles at a point are the measure of all angles with the same vertex, and that means that the vertex is right here in the middle, the same point where they come together. So we have angle ABC is 1, angle CBD is another, and angle DBA is the third. Okay, there aren't always three. There could be 4, there could be 8, there could be 12. It depends on how many different rays come off of the same point. But all of those, when you add them up, their ending amount or their total is 360 because it's a complete circle through all the angles. Okay, so angles at a point means the measure of all the angles with the same vertex, the same middle point, is 360 degrees. So we have angle ABC, angle CBD, and angle DBA, okay? And those all added together would make 360. Now, I'm not expecting you to memorize this at all. You do need to be aware of them, though, because the problems that we're going to work on in this lesson are directly related from this information. So this page is really, really, really important. Okay, I'm going to the next page so that you can see what we're going to do with this stuff. It is really fun. Okay, so again, angle problems and solving equations. I want you to check these out. In a complete sentence, describe the angle relationship and solve. So basically, you're going to get a picture of what you see. You have to tell me which one of those ones that we just talked about it could be, and then write an equation for it. So what you're given in this picture is you're given a straight line, so that's a hint, angles on a line. Nice. So we would say the first one represents angles on, I should be able to write better, angles on a line. And since we know that the angles on the line is the one where you have all of your angles adding up to 180. So the degree measure for angle BAC is how much? 3x degrees, okay? The angle measure for CAD is how much? It's sitting right here. What is that, everybody? You are correct, 90. So we write 90 degrees right here, okay? You can't see it, so I'm going to move this up. And then you have the last one, which is DAE. What is the angle measure in there? Plus 2x degrees. And all of those, because it's a straight line, equals how much? If you can't remember, flip the page. I remember it's 180 degrees. Okay? So now, what do you see? What is this? I'll give you a hint. It looks like a what to me? You are correct, an equation. But before we can make it a real official equation, you have to combine like terms. So this has an x in it, this has an x in it. What's 3x plus 2x? If you said 5x, you're correct. So this would be 5x degrees plus 90 degrees. We cannot combine these two because this one doesn't have an x, and then all of them equal 180 degrees. Now, kiddos, what do you notice about this equation? You could use your what? Your BU chart. Okay, so let's take a look at it. The variable is x. What did we do to x first? We multiplied it by 5. What did we do second? We added 90. So to undo that, we subtract 90, then we divide by 5, and we should be left with x. So now let's try it. So we're going to subtract 90 from both sides, and I already know by looking that 180 minus 90 is 90. You all should be able to recognize that by now. And we're left with 5x degrees equals 90 degrees. Then the next thing in our BU chart says to divide by 5. So I'm going to divide this side by 5. What you do to one side, you have to do to the other. 5 divided by 5 equals 1x. 90 divided by 5 equals, 1 time. That's 4 left over, 18. Okay, so that's 18 degrees. 1 times x is x, so x has to equal 18 degrees. Now, the only thing that I'm going to throw in there is this is just x. In your practice problems, they're not going to want just x. What are they going to want? They're going to want 3x. So then you have to go back and take whatever x is and multiply it by the coefficient. So what is 3 times x? Well, 3 times x is 18, so you're going to do 18 times 3, and you would get 54. So this angle right here, BAC, is 54 degrees. And then this one, 18 times 2, is 36. Hold on.
Jennifer Goodell, please come to the office.
So now we have 54 degrees plus, how many degrees are in here? 90 degrees plus 36 degrees. All of that should be 180. Let's check. 54 plus 36, that's a 10. So I can do a 0 here, regroup. So that is 5, 6, 7, 8, 9. And then we have plus 90, which is right here. 90 plus 90 equals 180. Let's see, 90 plus 90 is 180. 180 equals 180. So it checks out. Okay? What do you think? Find it? Pretty fun, isn't it? Told ya. Okay, let's do the next one. And then I'm going to leave you 2 to do by yourself for homework. Okay, so here's the next one. Here's the picture. Look at it. What does that one look like? I'll give you a hint. Ta-da, 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 ta-da. What do you see? All right, I'm going to say vertical angles. Vertical angles. And what did we learn about vertical angles? That they equal each other, okay? Vertical angles mean that they are opposites are exactly the same. So right away, what did we figure out about one variable? If this is 144 degrees, what does this y right here have to equal? Well, this y right here has to equal the exact same as this up here. So we now know that y degrees has to equal 144 degrees. Okay, so now you're sitting there going, well, Mrs. Nelson, why does that help me? Well, it helps you because this right here is a straight line. Do you see it? That's a straight line, and we learned from angles on a line up above that this plus this equals how much? 180, you're right. So now we can write the equation 144 plus x equals 180. Did you just find the equation? And the answer that you need to say is yes. So do your BU chart really fast. We have x as the variable, nothing multiplied by it, but what is added to it? 144. So how do you undo adding? Subtract 144 over 3.
Would Harry Lakin Smith please come to the office? Harry Lakin Smith, please come to the office.
So now we're going to subtract off 144 from both sides. And let's see what we get. 0 pair, x equals how many degrees, everybody? 36 degrees. So we know that y is 144 degrees, and we know that x is 136 degrees. Or not 100, 36 degrees, sorry. Sorry. Y equals 144 degrees, x equals 36 degrees. Okay? How you feeling? Okay? I hope so. All right. So your homework, well, not homework, but your keep working practices are this little guy right here. So I'll let it sit there for a minute so that you can get it drawn. Okay? And then the other one is this little guy right here. Remember, you need to figure out what kind of angle relationship this one is. I'll give you another hint. Here's a straight line. Da-da-da. Oh, this is not a straight line on the next one. Look. That one's not straight. It bends. That one bends. So I'm going to give you another hint on this one. If I point to right here, what does that tell you? It's where they all have a common vertex. So the one where they all equal how much? Common vertex, all of them equal how much? So your job is to figure out. You need to tell me what x equals on this one, because you know this one already and you know this one already. You need to tell me what x equals on this one, and you know this already, and the straight line. Okay, those are all the hints I'm giving you. I want to see if you can do it. Okay, that's it. Oh, let's go back to our question of the lesson. How do you write an equation from a word problem? What do we look for? Most important words, anything you know that you can substitute a variable for. Okay, think about that. All right, I hope that you are going to have as much fun with this as I do, and I will see you all tomorrow.